All right, everybody, this video is going to be going over Lab 2. So we're going to go to the lab section. Going to go to Lab 2. This will be available for you guys. And then this lab comes with a PDF and a few resources. So you can open the PDF and read it. But clicking on this link will download the resources for you. You'll get three things. You'll get dateapp.java, date.java, and then a spreadsheet. And the spreadsheet will be used for the submission. All that's covered in the PDF. The goal of this lab is we're just going to make a little program that will validate a inputted date as well as move a date to the next date, so the next day. I should say the next valid day. So we're going to start by creating a new Java project. If you have no projects, you'll be able to create it there, but everybody should be able to file new Java project. I'm going to name it. I'm just going to name it Lab 2. Leave everything as default, then finish that up. Next, I'm going to open it up on the side on the Project Explorer and right-click Source, and I'm going to say New Class. And then the name of my classes have to match what I downloaded before. So I downloaded dateapp.java and date, so my class names are going to be dateapp, and then I'll finish, and then I'm going to make one more and call that date. Okay. So now I have these two Java files, and I'll just copy paste what I downloaded before into these files. There's date app, and then here's date.java. Okay, so for this program, for this lab, you don't need to modify date app. So we'll see if I go ahead and run this. We see I already get the prompt, input a date in the format month, day, year, enter Q to quit. So I can enter, 12/1/2020, and it'll spit out some output. The input date is yeah, and then Q to quit. So the new date, our program would want to increment this by 1 day. But obviously that's not implemented yet, so that's something that will be left up to us. And that's something that's going to be implemented in date.java. So all your modifications are going to be to this program right here. And we can see some of it's already commented in. So we have these two methods, is legitimate, which takes in a month, a day, and a year, all as integers. And then there's some comments, trying to help us out with determining if it's legitimate or not. And then we have advanced date, and that's going to increment the day by 1. And we can see that that takes in this this date object, which is has a month, day, and a year. Okay, so some tips for is legitimate. This method just returns true or false. True if the date is valid, false if it's not. Examples of a invalid date would be -1 2020. So there's no negative numbers for dates. Similarly, there's some tips here about the leap years. So if February 29th is only a valid date on some of the years, so that's something you have to take into account. Other things you have to take into account are the dates of the days in the year, in each month. So some months will have varying number of days, and that's something that you need to keep track of. And as a quick little hint for that, there's a few ways you can do it. You can either have a bunch of if statements. That's valid. So if the month is 1 and the day is greater than 31, because there's 31 days in January, then we know it's an invalid date, and we can return false in that case. And we can do something similar for all of the months and for the days. Alternatively, you can set up an array to do it, where every month is an index in an array, and every element in that array is the number of days. Alternatively, you can also do a switch statement. So there's a bunch of different ways you can do it, a bunch of different kind of structures you can do that for. You can just pick one. For basically, this method is going to end up with a lot of if statements. You're going to have a lot of conditions for the year, especially this one is going to get a little, you have a bunch of conditions here. So, the February only has 29 days if the year is divisible by 4 and it's not divisible by 400. So there's an if statement right there. But all in all, that's a pretty straightforward method. Next is the advanced date. So this takes in a date object, which if we scroll up, it has 3 attributes: the month, the day, and the year, all stored as integers, and we can see that right there as well. So we'll be able to access this date by saying a date dot month, and that's going to be an integer. So if we wanted to check if the month was 1, we could say if date equals 1, and then we can do something there, and we can see that I've accessed the month by using the dot, and that will give me access to these attributes. And we can do the same thing for the day and the year. So that's how we're accessing the month, the day, and the year from this date object, as opposed to this other method where we're accessing them directly. There's no need to access them because they're passed in as arguments themselves. So if I'm looking to increment the day by 1, I might start out with something like, okay, a date dot day plus equals 1. This seems reasonable. I increment 1 by the day, but now we run into this issue where what if I'm on the 30th, what if the current date was the 31st of January, and then I increment it once, and now I'm on the 32nd of January? Clearly that should be the 1st of February. And this is some logic that you'll have to bake into this method. So you'll need similar structures to the isLegitimate method. And again, there's a couple things you could do here. What you could try is increment the day by 1 and then check if that's legitimate or not. And then if it's not, then maybe back up, set the date to 1, and increase the month. And maybe your month is December, so increasing the month would turn it to month 13, which obviously doesn't exist. So again, you can check if it's legitimate. If it's not, make the month back to 1, increase the year, and kind of so on. Actually, I think that would be all the steps there. You could do it that way as well, and that would utilize this isLegitimate method again. Alternatively, you could bake in the similar logic as it isLegitimate to avoid that checking, adding 1 and then checking, is this correct? Add 1 more, check if it's correct. You can avoid all that by simply using that same logic and saying, well, if the month is 1 and the current date is 31, I know I need to increase the month by 1 and set the day equal to 1 as well. But again, however you want to do it, as with all programs, there's many ways to do it, all of which are correct. So whichever you're interested in. I will say the first one at least lets you reuse some of this code, so you don't have to redo that logic. But the second one does seem more like a cleaner solution to me, at least. But yeah, whatever does it. And we'll see that this is returns void. So we're not actually returning the new date. We are modifying the date of this object. So just like I did here, I set the day equal to 1 again, or I set it to plus equals 1. I change the value of the day in this date object. So it's not like I'm returning a new day object. You don't need to return anything from this method. You are modifying this original date. So once that's all done, you're given a spreadsheet, and the point is to make some test cases for this program. So you'll run into this with all your programs. How do you know if they work or not? Well, you need to make some test cases. Those test cases should cover most, if not all, hopefully all of the edge cases that you might encounter. So some edge cases in this program might be, a leap year is an edge case, or rolling over a year. If your day is December 31st, what happens when you increase the day? It should be January 1st of the next year. And these are all edge cases that you can test. That these are cases that are different than just the standard increase the day by 1. And hopefully through these tests and testing these edge cases, they all are correct, and you can be confident that your program is working correctly. So that's the point of the spreadsheet. You're going to make your own test cases. You're going to give an example of why you made that a test case. You're going to say what the expected output of that test case is before you run it. This is kind of important. I know it's really easy to, cheat and run your program and then say, oh, well, yeah, that's what it should be. But the importance of test cases is really to ensure that your program functions. So it doesn't make a whole lot of sense to build your test cases around what your program currently outputs. It's much better to build your test cases in such a way where you know what it should output, and hopefully your program matches that. And that will kind of avoid those issues where your program is wrong, and then you said that that was the expected output of the test case when in reality it shouldn't have been, and it passed the test just because you copied in what the program output anyway. So really try to make those test cases before you run the program. And I believe the PDF mentions that you'll have to submit 2 spreadsheets. One of them is with the test cases and the expected outputs, and the other is the test cases, the expected outputs, and the outputs of your program. And I mean, obviously, that final spreadsheet, it's going to match. Otherwise, your program doesn't work, and then you'll have to go back and fix your program. And hopefully, by the time you're submitting the lab, your program actually functions. But that's what you'll be submitting for the lab. So hopefully that was clear to everybody. Best of luck with it.